We'll just wait a few more minutes till a few more people join us.
Sorry, what was that?
I just said I will wait a few more minutes before we do the general introduction.
Yeah.
By the way, both of you, the name for both of you is John. So
Yeah, I'm John Jr. No, I actually piggyback off of John's hosting
okay.
because I typically have problems getting in. So John's given me the secret okay handshake to basically either host or co-host these webinars.
Yeah, so WebEx doesn't allow you to, it's in my account, but if I wanted Claude to do all the, what he's doing, he had to actually come in as under my name, which is really a bit bizarre, but that's the only workaround, which is fine. So
Yep.
it's not the easiest program. When we first started, we were stumbling out of the blocks a bit, but now I think we got most of the bugs worked out, eh, Claude, at this stage?
Yeah, I also use Zoom, and I find if you really look at most of them, even a simple thing such as Skype, they're all pretty similar. Certainly, Zoom and WebEx and some of the more commercial, higher end products have a few more toys, bells, and whistles with it.
Yeah. We use Teams mainly for our internal meetings. We use Teams, Microsoft Teams, which is based on Skype.
Yes.
There's also Google, the how do we call it, Google Do or something like that, and that's also that I figured that's the fastest. I use Zoom as well sometimes, but I found Google to be the fastest. They have the best artificial intelligence, and all of these are helped by artificial intelligence. But X is the one that NRC actually has a solid contract before the pandemic. But after the pandemic, they have a contract with Microsoft Teams as well.
Yeah.
So,
yeah, there's a lot of good products out there, and certainly these days, I'm sure everybody's getting their eyes opened up with all these different opportunities to basically communicate this way.
yeah, of course.
So shall we begin, John?
Yep, I guess, well, we usually wait about 3 to 4 after.
Okay, I'll wait another minute or two, and then we'll get going.
But given that it's a recorded presentation, we can start on time, and whoever joins later, they can always rewind and look at the first part that they.
I don't disagree. So first off, for those that are on board and those that will be joining by the recording later, we want to present today's speaker on the topic of, what was the topic? Steel
helical piles.
Helical piles. And Ali's going to give us a really good overview. Certainly, John and I enjoyed his presentation last year up in Ottawa. It was certainly a splendid, excellent presentation. But anyways, a little bit about Ali. Master of Science in Civil Engineering from Concordia University, a PhD candidate at Concordia University, 12 years of experience in the field of consulting engineering in Canada and internationally. And he joined CCMC as an evaluation officer in 2018. Now it says here a little note, big fans of, what's that team? Montreal Canadiens.
I thought it was Toronto Maple Leafs.
Well, we were going to.
No, don't say that to me. Like, I mean.
Toronto who? and of course, down in my area, it's we call it Detroit Dead Wings.
Exactly.
Whenever I go to Toronto, I make sure to wear either a jersey of Montreal Canadiens or a T-shirt of Montreal Canadiens. And I'm not afraid of confrontations.
Okay, Ellie, we're going to hand it over to you. So everyone, please enjoy. This is going to be a very interesting webinar.
And you got the recorded button on, Claude?
It certainly is recording.
All right.
Okay. Hello, everyone. My name is Ali Reza Ifar. I'm an evaluation officer at CCMC in Ottawa, Canada. And today I'm going to be presenting the steel helical piles. It's more of an overview with the main focus on the relationship between CCMC and the authorities having jurisdiction, be it a building official or a building officer. And hopefully I can finish this between 40 to 45 minutes, followed by 15 to 20 minutes of Q&A. So feel free to keep your questions for the end of the presentation. As a summary for this presentation, I will have a quick introduction about this system. What is a helical pile? How do we deal with it, and what's the advantage? Who made it first? This is a main issue. This is an interesting issue because everybody is claiming to be the first one who invented this system. And then the history and the state of helical piles at CCMC, where I work, and the main theme of the presentation, which is when to contact CCMC when you have questions. So we can start the introduction by talking about what a helical pile is and what kind of name we should associate with it. So first thing that comes to mind is it actually a helical pile or a screw pile? Because I hear the screw pile a lot. So well, if you Google the term helical piles, it will return 820,000 results, which is interesting. That's a lot of results. But when you Google the term screw piles, it will return 7,400,000 results. So it's clearly a screw pile. It's like, it's not even fair to compare these two names together. You know, it is a screw pile, it has to be. But no, the reason that we have so many terms returned for screw piles and so little for helical piles is that the term screw pile was used originally when this kind of system started everywhere. But recently, in the 21st century, we have new publications like this one, the textbook by Howard Perko on helical piles, a practical guide to design and installation, which he used the helical pile as the definite term of to address these kinds of piles. And this is the reason. The reason behind this is that the geometry of the main part of the pile should be a helicoid. The geometry should follow a helix timeline. And then we have the Deep Foundations Initiative in United States. They issued their guideline, their design guide for helical pile foundation, and they again use the term helical pile. So this is the term that we are dealing with nowadays with these kinds of systems. And also ICCAS, they also refer to this system as helical piles. And after all of them, CCMC is also deciding on using the term steel helical piles for these systems, because right now what we have in our technical guide is called auger installed steel piles, which is not a very good term. So we are changing that to helical piles. So this is about the name. And before we know anything about these piles, we need to know a little bit about the geotechnics. We need to know a little basic geotechnical terms and geotechnical background in order to be able to see this system, to review this system. So whenever you want to build a building, a structure, let's say a column, you want to put a column on soil and you want to put load on it. Chances are when you put the load on that, it will start to sink. And the reason behind that is that soil is not as strong as concrete or steel. So whenever you put the steel or concrete on soil, it tends to go in. And we have a frost line, obviously, that complicates the things. So we need to make sure we have a foundation under the column. So the best way for many applications, the most popular way is to dig below the frost line, build a footing mainly of concrete, mostly of concrete, and then build a column on top of it. And then when you put the loads, the pressure is distributed over the soil so it won't sink into the soil. Now, there is a big challenge with that, because when you're dealing with concrete, you have to always keep in mind that concrete needs to be cured. And curing of concrete relatively is a long time. 7 to 28 days is required for the concrete to cure. And given the fact that in Canada, and more particularly in northern Canada, the construction season is so short that we have to literally save on days. We need a system that doesn't require curing time. And that's when the helical piles come into play. You can just drop the helical pile, drive it into the soil, pass the frost line, and then you can build your column and put the loads, and the loads will create a pressure into the soil, and you need to design it respectively. And in some cases, when that pile is not sufficient, the loads are higher, or the depth is not meeting your requirements, you can go deeper. You can have a longer helical pile with maybe more than one helical bearing plate, and you can build on top of that. Now that we know that how the helical piles can help us, we can see a helical pile and check what are the main parts and components of such a system. So, like I said before, the main component of a helical pile is the bearing plate. And depending on the number of bearing plates on a pile, we can call them the lead helical plate if that's the first plate on the pile, the first one that gets into the soil. And this plate is connected to a lead shaft, mainly by means of welding. And if we need more than one plate, the second, the third, more plates, we can weld them on the shaft, and those are called the trailing helical plates. And if we need more depth, if we need to go deeper in the soil, we can come up with optional extension shafts, and those extension shafts are connected to the lead shaft by means of a coupler mechanism. And that coupler mechanism could be bolted or welded. The main thing is that the details of that coupling system should be predefined. And then once we have our pile installed in the soil, we need a pile head assembly to basically connect it to the building and transfer the load from the building to the soil using that pile. Like I said, the main component of a helical pile is the bearing plate. But the bearing plate also has two components. The first component is the leading edge, the lower edge that first meets the soil. This is the edge that cuts into the soil and advances the pile in. And we have the trailing edge. But the distance between the leading edge and the trailing edge is the characteristic of the pile, which is called the pitch. So any type of pile has certain characteristics. The diameter of the shaft, the thickness of the shaft, the diameter of the bearing plate, the thickness of the bearing plate, and the pitch. These are the parameters that we can play with to have new different types of piles. So we can have as many types of piles as we want by just changing those parameters and come up with new piles based on the requirements of our design. Now, the main advantage of helical piles over other kinds of steel piles is that these piles are driven into the soil by means of torque application. So we put the pile on the soil and we torque it in. We apply torque on top of it and it advances into the soil. This process, the process of screwing the pile into the soil, creates the leading edge of the bearing plate to cut into the soil. And that represents a famous test for checking the resistance of soil, which is called the plate penetrometer test. This is resembling that test. So based on that, people in the literature are calling for a direct correlation between the applied torque and the resistance of the pile to the applied axial force. So, and there are many, many different tests and publications that correlate these two in forms of a value called KT, or capacity to torque ratio. And there are well-established literature on that. So the main advantage of this pile over other kinds of piles is that you are basically testing the pile as you are driving it. Now it gets us back to the point that who made this pile first? Now, everybody in this industry, like many other famous industries, claim to be the father of this system. If you go on the website of any of the pile manufacturers in Canada or United States or anywhere, you can find some small short history that they claim that the person in charge of that company is actually the first person who came up with the idea of helical piles. Now, do you believe it? How to check it? I don't know. Let's see who made these piles in the first place. And if you want to have any guesses or anything, I can give you some time to think about it, or Google who made it, or let's just have it. This is the guy who invented the helical piles. This is the guy who came up with the idea of a screw that can be drilled into the soil and act as a pile system. This guy is called Alexander Mitchell. He came up with this idea a long time ago, 1832. At the time, he was legally blind, so there was no way for him to visualize the thing, so he used his senses. This is a lot to handle right now. The guy was blind. In 1832, he came up with this idea, and he used that idea, he used that terminology to design the foundation for this structure. This is the lighthouse called the Maplin Sands Lighthouse, and it was in Ireland. So he used 9 of those piles, and he drilled them into the seabed to build that lighthouse. How did he drill that? How did he drill those piles in the seabed? You guessed it right. He hired a bunch of workers. He asked them to go and drill the pile in. This method is not recommended these days because we have labor laws in place. So this is not recommended, safety reasons. But 200 years ago, this is the way they did it, and kudos to them. So this guy, almost 200 years ago, he came up with this idea and he built that structure. Now, that structure doesn't exist anymore, but it was such a significant building in British history that a model of it, the one that I'm showing right now on the screen, exists today in the Museum of Technology in London, England. So whenever you go to London, England, please go to that museum. It's free of charge. You can go in and please take a selfie and send it to me. Thank you. And this guy, Alexander Mitchell, when he came up with this idea, he did the right thing. He did what you should do when you have an excellent idea. He patented it. And he patented it in 1836. But right after that, when he built that lighthouse, people realized that this is actually an interesting idea. So other people also started some patents. So between 1830 and 1875, which we call the Marine era, some people submitted 5 US patents for moorings, lighthouses, applications of helical piles. But then after that, in 1875, people started thinking about applying helical piles for fence posts. So, and that's where the agriculture era starts. Between 1875 and 1920, people started submitting patent applications for helical piles, 20 of them, to the US Registry of Patents. And then after that, 1920 to 1985, in utility era, people have started to use these helical piles for pipelines, guy anchors, industrial applications. And then after that, all over the construction business, in sheds, mobile homes, decks, buildings, underpinning, walkways, you name it, any kind of application, helical piles can be utilized. And there are 100 patents since 1985 until today in the Registry of US Patents. In total, we have more than 165 patents right now existing for helical piles, which is significant. And when it comes to Canada, CCMC deals with helical piles. CCMC is in place to help the building officers, having jurisdiction to deal with all different kinds of building and construction products, including the helical piles. The first application for helical piles received in 2000, and based on that application, CCMC came up with a technical guide to evaluate such a product in 2001, and the first evaluation report was granted in 2002. After that, until today, we have 13 evaluation reports existing in the current CCMC registry, with more applications to come. And the technical guide for the evaluation of helical piles has been drastically updated based on the state-of-the-art literature and all the new findings in this industry. And once this technical guide is certified, once this technical guide is officially out, which we expect in the coming days or weeks that happens, we will start updating all the existing evaluation reports based on the new technical guide. So this industry is definitely working really fast. Now, before going any further, I need to remind you guys that CCMC and CCMC evaluation reports are in place to help you guys, to help the building officers, to help the authorities having jurisdiction to verify, approve, or reject helical pile applications. You can use our evaluation reports when you are making a decision about those applications. And one very important thing is that please pay attention when you are dealing with a helical pile application. When you see the evaluation report, please pay attention to the type of helical pile. Like I mentioned before, by changing the diameter, the thickness, the components of a helical pile, we can change the types of helical piles. So a manufacturer might have many different types of piles, but only a few of them are evaluated by CCMC. So this is one of the things that you have to pay attention to it. And I will return on that in the upcoming slides. Now, CCMC, when there are issues with some of the products or some applications, we issue technical bulletins. And with respect to technical piles or auger installed steel pile foundations, we issued in 2018 a bulletin that covers 6 main issues with these piles, as a reminder to the building officials, to the building officers, to the authorities having jurisdiction across Canada, about the CCMC number, about piles with a valid CCMC evaluation reports. We wanted to remind you guys about the helical blades, what's important about helical blades, about the installers, who is certified to install these piles, about welding, and about corrosion protection, and ultimately the engineering required for these piles. Now, I will go through each of these points in details. First things first, what's significant about CCMC mark and evaluation report? It is very important to check for the CCMC mark. It looks like this, and it could be on any product. When this mark is on a product, it means it was evaluated by CCMC. Once you see this mark, you have to check for the evaluation report. So the number that you can see on the mark should be associated with an evaluation report. The evaluation report is on our online registry. and you can receive it. You can go through it. In that evaluation report, it is very important to see the articles and clauses of the National Building Code that product was evaluated against, and the types of product that was evaluated. This is very important. In the second part of in the section of every evaluation report, there is a description part. And in that description part, the types of product are completely explained. So there might be a helical pile manufacturer who has like more than dozens of helical pile types, but only in this case, for example, only 3 of them are evaluated. So it is very important that you receive an application, you check those piles in that application against the evaluation report. And once you do that, you should always check the CCMC registry, because sometimes you have the evaluation report, you saved a copy on your computer, you printed a copy, but you always have to check the online registry, because sometimes the evaluation report might not have been updated, or it might have been updated with new information, or simply sometimes it might be suspended by CCMC based on some technical issues. So it's very important to check our online registry all the time when you're dealing with an application. It takes less than a minute. You just type in the CCMC address and you get the most valid copy of the CCMC report. And remember, whenever you're in doubt about any product, any CCMC evaluated product, please contact us. We are making sure at CCMC that any question, any inquiry raised by an authority having jurisdiction, or in some cases by engineers or homeowners, is addressed within 3 business days. So this is what we are trying to do. And I received many different inquiries from authorities having jurisdictions, homeowners, or engineers about helical piles, and I addressed all of them accordingly. Now, coming back to the main issues with helical piles, we need to check the bearing plate. We need to check if the bearing plate follows a true helicoid geometry. And the way to check it is to measure the pitch at the tip of the plate and at the base of the plate. And these 2 pitches must be the same, give or take. 3 to 6 millimeters of difference is acceptable. And if that is acceptable, it is written in the evaluation report. And the second thing that we have to check is the bearing plate has to be perpendicular to the shaft at every point. So if you measure that, it should be 90 degrees. We ask all the manufacturers through the evaluation procedure to provide us with those data. CCMC is always trying its best to make sure that the helicoid geometry is respected. But sometimes the building officer, the authority having jurisdiction, has to do their due diligence to go to the field and just check randomly 1 or 2 piles to see if they are helical. You don't actually need to have any equipment. You can just recognize if it's a true helix or not by just looking at them. The right one, the picture on the right, the one that has galvanic protection, is a true helicoid. The one at the left, you can see the duck beak. That is not a true helicoid. That's why the one at the left is not CCMC evaluated, is not approved by CCMC. Even if it has a CCMC number, it's immediately deemed not evaluated by CCMC. And you should raise a flag for those. There's another thing I need to remind you. Some of the installers, in some specific cases, when the soil that they are drilling the pile in is bouldersome and they hit a big boulder and they cannot drive the pile in, instead of excavating and removing the boulder, they just modify the bearing plate to form a seashell like the ones that I'm showing here. And by having a seashell geometry, the screw pile can go in many different hard soils, including boulders, without any problems. But this modification also modifies the capacity of the pile. And whenever this modification is in place, It's not CCMC evaluated. It's actually written in the conditions and limitations. In the new wave of evaluation reports, we are adding that condition that any modified bearing plate, it's out of the scope of CCMC. You should ask for engineering documents. You should ask for engineering calculations to support that, because by modifying the bearing plate, you're reducing the capacity of the helical pile. About the installations and details, all the installers of the helical piles must be certified by the manufacturers. You should make sure that competent installers are also certified by the manufacturers. And this is what we also ask the manufacturers to provide evidence on their certifications for the installers program in their quality control documents. Those installers, they must pay attention to details, and sometimes it's easy to find out where they are not doing right. For example, in this case, they drive the pile, and there was a little bit of misconfiguration, so they modified the top plate, they modified the top bracket, so they can meet the points they wanted to insert the pile. This is not acceptable. Or in some other cases, it's just bad engineering, purely bad engineering. And like in this case, they built a terrace over a scaffolding. This is not acceptable. This is engineering. This is not an engineering structure. So in that particular case, the order of engineering engineers got involved, and they actually shut down that construction. So these are the things that we have to look into. We have to be careful with those kinds of things. And welding. Welding is one of the most important parts of this pile assembly. Now, the welding quality is always checked by CCMC, because all the helical piles, all the main components are shop welded. CCMC always asks for the certification, for the welding certifications, for all the welders involved in the welding of the bearing plates to the shafts. But some of the manufacturers have some details about field welding. Now, field welding is not checked by CCMC. We cannot go into every field and check for field welding. But some of the manufacturers might have some details about field welding that are eventually evaluated by CCMC. The building officer, when you go to the site, you see a bad welding like this, it's immediately raising a flag. So if you see field welding, if you see an extension added to the pile, immediately you have to look on the engineering blueprint to see the details of that extension. And if it's field welding, all the details must be there. A welding like that, it's not acceptable. This is low quality weld. This is welded on galvanized steel, and then there's no protections. It's probably not acceptable. You should ask the manufacturer to look into that. Many of the problems with piles, I would like to remind you, they can only be detected during installation, because after installation, you don't see it. It's buried under the ground. Lateral load resistance is not evaluated by CCMC. Any pile that is a part of lateral load resisting system of the structure is not evaluated by CCMC. So you should pay attention to that. CCMC requires the manufacturers to come up with case-by-case engineering design when it comes to lateral loads on buildings and lateral loads transferred to helical piles. So this is very important. Special design must be in place when lateral loads are involved. Engineering. So in general, for any project, you need to see an engineering blueprint. In that engineering blueprint, you will see the plan of the building or extension or whatever it is. The engineer of record must have calculated the base forces, the foundation forces. and come up with the number of piles required and the capacity involved with each of those piles. And those are marked on the engineering blueprint. And on that blueprint, the capacity of the pile is requested. Now, those numbers will go to the manufacturer. Another engineer at the manufacturer or hired by the manufacturer would design the piles. If they want, whatever procedure they want to use for the design, they come up with the capacity, the type of pile, the depth it should install at, or the torque required for the installation. They will come up with that design, and it will be marked on the engineering blueprint. This is very important. And the last point, the last technical point I'm going through is the corrosion protection. So the National Building Code requires corrosion protection for steel when the soil conditions are corrosive to steel. So any steel pile installed in corrosive soil must be designed for corrosion. There is a table that shows different levels of corrosivity of the soil, so severe, moderate, or low corrosivity, and this is based on a test on electrical resistivity of steel. This is a basic test that any geotechnical testing would be able to give you the results. So in cases that you have a building that the soil is prone to be corrosive to steel, you should require the geotechnical tests, and in those tests, the level of corrosivity of the soil must be determined. Once we have that, we can come up with the service life of the building. Now, we have the Canadian standard for the life expectancy or the service life of the building. So CSA S478 is the standard, is the Canadian standard for the life expectancy of the buildings. There are 4 different categories for the service life of the building: short, medium, long, or permanent. So your building might be between 0 to 300 years of service life. And for each of them, there should be a design regarding corrosion for the helical piles. And there are ways to calculate the actual thickness that will be corroded during the lifespan of the building. For example, AASHTO has this table, and in that table for different kinds of steel, including bare or black steel and galvanized steel, in all of those 3 different soil corrosivities, it gives you a millimeter per year of corrosion for the steel. For example, if you have bare or black steel in a moderate to high region, it means 0.033 millimeter per year. So, for example, if the service life of that building is 20 years, you know that you will need 0.66 millimeters extra steel to be able to be sacrificed during corrosion, so your design is right. All I want to say is that you need to make sure that if you have corrosive environments, the engineers should address that corrosion design in their engineering documentations, in their engineering calculations. And last but not least, I want to double down on this, that you should contact CCMC. When to contact CCMC? Whenever you are in doubt. This is an example. 2 weeks ago, I received a call from an engineer in British Columbia. She was claiming that she designed some helical piles. She used the website of the manufacturer. She contacted the manufacturer. They gave her some details about some piles, about the types of piles, and they told her that these piles are CCMC evaluated. Now she based her design upon those information and designed some piles. But when she received the piles in the field, they did not look like the ones in the evaluation report and on the website of the manufacturer. So she called me, she called CCMC. And although she was not an authority having jurisdiction, she was not a building officer, a building official, I answered her question. Those piles were not CCMC evaluated. those piles were not the same as those piles in the evaluation report. So she has a decision to make. She can contact the authority having jurisdiction, notify them, and those piles are not allowed to be installed. Or she can ask the manufacturer to come up with engineering calculations to support these piles. That decision is a wise decision. That decision is a calculated decision. And CCMC helped that engineer with making that decision. So if you have any doubt about the helical piles, feel free to contact CCMC, and that's the end of my presentation. If you have any questions, I'm here for you.
Thank you, Ali. I think we have a few questions here. John, did you want to go over your questions?
Sure. So, Ali, in the bearing plate, you talked about the pitch.
Yeah.
What about the width of the blade? Does that really matter? I don't know what's the width. Is it 2 inches? But what if you have could you have like a 4-inch plate or a 6-inch plate? Because the wider the plate, the plate, the more bearing it will have as a footing. Does that really matter? And can you have a difference in size of the pitch? So like the first plate may be smaller, but then the next blade, or do all the blades have to be the same size?
Yeah, that's a very good point, John. Thank you. And this is basically the main aspect of helical piles. The bearing plate has a bearing area, and that bearing area is the defining factor in the capacity of the plate and eventually the pile itself, right? So the larger the plate, the better, in theory. So if you have a huge plate, let's say 5 feet wide,
yeah,
and you can manage to drill it into the soil, yeah, you have a 5 feet foundation. But it's not the case, because when you have a larger plate, you will have more bending on that plate when it's actually up, when the soil pressure is actually applied to the plate. So there will be bending applied to that plate. So the plate should be large enough to satisfy the soil requirements, but it has to be small enough to be able to take the bending moments, you see? So the design is basically, you should find an optimized design between the structural capacity of the plate itself and the geotechnical capacity of the soil below it. And that's why we have so many different types of piles based on the diameter of the plate itself.
Right. Okay. So another question I have is soil conditions. So obviously you have to have a soil engineer to predetermine whether or not a pile can be used. Like what are the conditions to use a pile? So for example, in northern Saskatchewan, and again, Fond du Lac, which is the north, they're actually a sand dune, and their sand is soil. So you can, as the one inspectors, you can drill until hell and high water, it ain't gonna stop. So up there, they use wood foundations, right? And they shift, which is a whole another issue. But so I'm just trying to figure out when is the best to use a pile foundation. And I assume you have to have a soil testing done first, right?
Well, yes, that's highly recommended. We need a soil test to determine what kind of soil we're dealing with. The bearing resistance of that soil is highly dependent on the nature of the soil. Like these helical piles have different behavior in sand, let's say, than in till, you know. So there are many different experimental programs to determine the capacity of the helical piles in sand or in clay, in soft clay, hard clay, in all different kinds of soils. So a soil report will definitely help the geotechnical engineer who wants to design the pile. But when the loads applied on the pile are relatively low, and by relatively low I mean less than 100 kilonewton, we can use the available literature. We can use the available test results in which they established a correlation between the installation torque and the capacity of the pipe. Right? We can use those, but in major applications, in building applications, in engineering applications, we definitely need the soil report, and the geotechnical engineer needs those soil values to be able to calculate the capacity of the pile. Quite frankly, like any other foundation type, that we need the soil resistance, we need the soil properties to be able to design the foundation accordingly. Helical pile is no exception.
Right. So how popular are the pile foundations? Like I know a couple of people around, they use them for like extension of porches and stuff, but in terms of homes and larger structures, are they really popular, or are they becoming more popular? I just think of some of the indigenous communities, and I've seen some quotes. Like, I don't see any, and correct me if I'm wrong, any of the participants, but I don't know if pile foundations are really been attractive, or is it a shift and change in attitudes that they were? So I'm just trying to get a handle on that.
Mm-hmm. Well, in order to give you the popularity of these pile foundations, I just give you some numbers. There are 13 manufacturers with evaluation reports at CCMC. One of them, which is the oldest one, installed during the past 20 years, they claim to be installing 15 million piles.
Oh.
The second largest one, the second largest manufacturer, claims to install 1 million pile a year. And this is only in Canada. Just break down that number. That means how many projects? Like 1 million piles. If there is 5 piles or 6 piles involved in every project, this means 150,000 projects a year. Right? And that's for the second one. And we have 12 more of them. So these piles are definitely popular. These piles are definitely everywhere. And CCMC is trying to make sure that only manufacturers with sufficient QC programs, with sufficient competency are practicing. But quite frankly, this is a very, very simple building product. You just need a shaft, you just need to know how to weld, and you just need to know how to bend plates, so you can make those piles. And there are some smaller manufacturers, like Joe in his garage with a welding machine can basically make piles,
Yes.
And this is attractive for them, So helical piles are very, very popular, and they are gaining attentions everywhere. And we just need to make sure that there's sufficient engineering and quality control behind them, and these are good, very good foundation systems.
Thank you, Aldi. I have a question here from Dale, one of our participants. Do the piles need to be drilled down to hard pan? If so, do you tell that you have hit hard pan by the torque on the pile?
These piles do not require to go until they get to the hard pan. No, you don't need to get to the bedrock with these piles. You can actually establish a firm resistance by just passing the frost line. You can achieve a very good resistance by just going 6 feet low, like 6 feet below the surface. It gives you a lot of resistance. But again, we might end up with a soil condition that is so variable throughout the depth, that we might have higher resistance at the surface levels, and when we go deeper, we might hit a soft pocket, and we have to make sure that we pass that soft pocket, so the plate can actually establish the bearing area required. But they definitely do not need to get to the bedrock. No.
Thank you. I have another one here from Lisa, another one of our participants on board here. Does a pile have to be absolutely vertical, or can they be slightly angled? Seems to me we looked at something on that lighthouse, one of the earlier slides. So is that really the same condition today?
Oh, that's a very, very good question. Thank you very much. CCMC only evaluates plumb piles. And the reason behind that is that by just tilting the pile a little bit, you can get some lateral capacity as well. But at the same time, when you're applying a vertical force, you are somehow bending the pile at the same time. So because of that reason, CCMC only it's involved with plumb conditions, plumb piles. But yes, one of the ways, you remember I said there should be sufficient engineering when there are lateral forces involved. That's one of the cases. When you have lateral forces, you might end up having all the piles plumb, but some of them inclined on 45 degrees angle or something similar to that, and those can take the lateral forces. Yes, and in the lateral force, the Maple Sands Lighthouse, the 8 piles all around the foundation were inclined by 15 degrees.
Okay, we have another one here. We have a lot of ledge rock here in their particular area. Can pile drill through the rock? If so, how deep?
Usually when we have rocky kind of like where I live in Elmer, Gatineau, you just start digging the soil and you just go 2 inches below the surface and you hit the rock. In those conditions, drilling of the helical pile is a little bit too difficult. And in those cases, those might come with ideas with having modified blade, might come up in cases when you want to surpass the boulder, you want to go through the boulder, you want to go through, you reach the level requested, or you need a special detail. And because of especially, it won't be CCMC evaluated again, but there are engineering solutions for that as well. Yes, you can drill it into the bedrock. If you have weathered bedrock, not firm bedrock, but weathered bedrock, you can actually drill the pile into that.
Again, thank you.
No problem.
I just want to ask, are there any other questions that are remaining out there? Or John, any other thoughts? Well, it looks like we don't seem to have any.
Oh, there you go. I was on mute there.
Okay.
So I guess the piles. So so the key is the engineering report, and they will determine the distance between each pile as well as the depth of the piles. Correct?
Could you repeat that question, please, John?
Yeah. So if I was going to do let's say build a house.
Yeah.
And I want to use pile foundations. So I guess the first thing I do is I get a soil engineer, and then the engineer has to tell me how many piles I need for my house of 1,200 square feet. So then it would determine the number of piles across. Yeah.
So the way it is that you want to build a house. you hire an engineer to calculate the loads applied on the piles. So that engineer must take into account that loads, live loads, wind loads, snow loads, all the loads by the National Building Code, and they come up with the base force, the foundation force, and then they distribute that foundation force over a number of piles, like exactly the same way as we do with regular foundations, and they have to have a firm understanding of the helical pile, that engineer,
Right.
but not with so many details. So they just need to know, give or take, how much capacity can they rely on when they deal with helical piles, and then they give those forces on a blueprint, on an engineering blueprint, to the manufacturer. And the manufacturer will hire a geotechnical engineer, or they have geotechnical engineers in-house that are specialized on these pile designs, and they design the pile according to the forces given to them by the engineer of record.
Okay.
Ali, I was going to ask about maybe some of the construction economics.
Okay.
Is this system a reasonably priced system? I mean, is it comparative to other foundation systems as far as cost? Or would you know that?
Well, that's one of those questions that I wish I could answer. I wish I had the knowledge to answer that. But unfortunately, I can't answer that question. I don't have the sufficient knowledge to answer that question. But one thing that I can tell you is that sometimes when we are dealing with building construction, the value of a system is not mainly the monetary value. Maybe sometimes time is of such importance that if I can save only a week in the construction, that would worth a lot of money. And that's why I rule out some of the systems that are more time consuming. That's what I would say. But other than that, when we are looking at the popularity that these piles are gaining in Canada, they must be economical, you know. They couldn't sell 1 million piles a year if it's not economical. If it was like, when you compare it with the sonotubes, yeah, sonotubes are quite popular everywhere. When you compare it with them, they should be able to compete with sonotubes if they want to replace them. And it looks like they are okay, I guess.
Thank you. I know that's a hard question to really answer, but much appreciated.
Yeah,
That's
because
my humble opinion.
Yeah, because if you look at, for example, the permanent wood foundations, which are, I think, fairly popular in a lot of the indigenous communities, mainly because of, of wood and access. Well, the price of wood, my understanding, it skyrocketed over the last, as a result of COVID, up to 35–40%. And I'm just wondering, given that the permanent wood the cost of wood has skyrocketed, and metal has almost relatively hasn't changed in terms of price points. I wonder if there's going to be a shift in thinking of using pile foundations as a form of a cost, and B, I think it would also just be, convincing a lot of the communities that pile foundations work. Like that, it's a probability. And so it's almost like, ICF forms and styrofoam foundations and concrete foundations. It's a lot of probably attitudes and, learning. But
yeah,
I just looking at pile wood foundations, and I know I've been talking, CMHC had rapid housing, funds for rapid housing. And a lot of the communities, their price points, it was like 35–40% increase just because of wood cost.
Yeah.
So I'm just thinking maybe this might be an alternative, especially when you can't get especially concrete in the north. You can always drop a pile foundation during permafrost. You can do that anytime.
Yeah. There are two things I need to. Did you finish? Did I interrupt you?
Yep. Thanks.
Okay. Sorry about that. So there are two things here. One of them is that when you're comparing the prices, you should always take into account the shipping costs. When you're shipping to the indigenous communities, most of them or some of them are not regularly accessible. Some of them are only accessible by means of air travel. So the shipping would be a big factor. When I want to ship the piles from, let's say, New Jersey area to Iqaluit, for example, shipping would be of concern. The second thing is that we need to make sure if we can actually drill these piles in the permafrost.
Wow.
Because, drilling in the permafrost is a very sensitive issue, right? And I'm not sure if the jurisdictions allow for such a thing. I'm not sure about that. That's one of the things that the AHJs can double check. If I'm a pile manufacturer and I want to get into an area, the first thing I would want to know is that can I actually install those piles in the permafrost in that area?
Yeah. Good comments.
Yeah. But aside from those two, these piles can be installed anywhere. They can install them in the permafrost. You can get into the firm soil level. There's no problem. I'm not saying it's the same as installing them anywhere else. I'm saying is that they need special attention. But once that attention is paid, you can design it accordingly.
Any other comments, questions? Lots of information, Ali, to think about here.
Yeah, but I don't want to close the door here. I want to keep the door open for any of the building officers, any of the building officials, any of the people who are concerned with these systems. The communication door is always open between CCMC and authorities having jurisdiction. You can always send me an email, ask your questions. I can direct you to references. If you're interested in this system, I can send you material to study about it. The door is always open. Like, we want to keep the communication open all the time.
No, I think that's much appreciated. It's great information, and again, it's just another option that a lot of the communities have in terms of their construction practices. So again, Ali, thanks for the presentation. It was wonderful, extremely informative. And
that was my pleasure.
And I wish everyone safe. And our next webinar is, Claude, I think February 25th, and that's going to be Tawasswan First Nations, I believe, giving a presentation.
Yes, that's correct.
Yeah, so we've got a bit of a time here.
And certainly down looking ahead, John and I have been, I guess, diligently working on a number of new webinars. So just kind of keep it in mind that keep a lookout for up and coming new webinars. And again, Ali, thank you very much. I think everybody very much appreciated.
All right. Thanks, guys.
Thank you, and have a nice day, everyone.